This is the Amp Hour Podcast. Recorded previously, but released March 19th, 2017. Episode 340. An interview with Jason Cerundolo.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And I'm Jason Cerundolo from Cast AR.
Hey, Jason.
Welcome, Jason.
Hey, how's it going?
Hey, Cast AR
it's familiar.
Alumni.
Cast AR, yeah. What is something Cast AR? Who do we always talk to about that?
Yeah, so we're making an augmented reality gaming system so you can play 3D holographic games in your living room.
Awesome.
Yeah, Can we have like an update here? Because we've had Jerry on before, of course, who founded Cast AR. Or was it? No, it wasn't called Cast AR back then. It was Technical Illusions. And then you sort of pivoted, changed names, and went in a different direction. Are you able to talk about that direction change and how you refunded backers and stuff like that? Because I don't think we've...
we covered all that stuff in the past, though.
Did we? Have we?
Yeah, we've covered that before.
Did we have Jerry back on after that fact?
I think so, yep.
Oh, okay. Well, how long have you been there, Jason? Give us the background.
Well, I've been here just over 2 years.
Yep.
And I started in 2015, right after the company moved down from the Seattle area. So I was here when we raised our Series
Valley,
A.
Right?
Yeah,
Where are you guys at
right
the
now
moment?
we're in Palo Alto.
Yep. Which is as Silicon Valley as you can get, really, isn't it?
Yeah, right.
Yeah, it's pretty much
It's
the
actually
in the
iconic.
HP garage.
Right, we're practically in the garage, yeah.
Yeah, and so a quick update is we're still planning on launching the product this year. Schedule is going to be a little tight, but we think we can hit it. It'll probably be a bit of a soft launch. It won't be a huge deal like hitting all the retail stores and everything right up front. But yeah, I know you guys covered the Kickstarter situation. I feel like that was a pretty good summary there. And so right now we're trying to raise our Series B. We're in the process of closing a round right now, and soon we'll have the money that we need to go through launch and aggressively hire a bunch more engineers and other people.
And everyone gets a smaller cut as a result.
Well, you got to build a bunch of hardware too, so that ain't easy. So that's
how much did you get in Series A? I forget. Was it 20 million?
Yeah, it was 15 million.
15, right. Okay, so that wasn't enough. You need more. It's a money thing. Now you need more money to expand and take it to production.
So we need money just for the bill of materials is one thing.
Yeah, right.
But in addition to that, big cost obviously is the engineering talent and
of course,
the salaries in general.
You should just take a pay cut, Jason. Come on, man. Just go for it.
Yeah, work for
volunteer.
Pizza and the
I hear
good
it's
of
really
humanity.
cheap to live in Palo Alto or nearby.
Well, we're at over 100 people right now.
Wow!
Holy crap!
Wow, that's big. Yeah.
Yeah, we've been growing quite a bit recently.
That's a lot of cash. That's a lot of cash flow.
That's a lot of burn,
yep.
baby burn.
Burn rate, yep.
Yeah, it adds up pretty quick. So we have our bulk of our engineering team here in Palo Alto, and we also have a first-party game development studio out in Salt Lake City.
Right.
That's right. I remember that was like former Disney people or something. I remember hearing about that, right?
Yeah, I started with them, and then Eat, Sleep, Play, and a couple other, not acquisitions, but we've gotten a lot of developers from other studios, and they're going to be developing content exclusively for Cast AR.
Got it.
Cool. That's great, man.
So they're out there because that's where the talent was that you wanted. So you just left them out there.
Yeah, it was kind of a good opportunity when Disney Infinity was shutting down.
Oh, we haven't heard. Have we discussed that before, Chris? What's Disney Infinity for those who don't know?
Well, they were doing I believe the Skylanders type stuff, and
what's Skylanders?
Some sort of little physical toys that interact with the virtual games.
Oh, okay, right.
So Yeah, so that sort of thing is right up our alley. We want to merge the digital realm and the physical realm.
Cool.
Yes, because you interact. The whole idea of your thing is that you don't just sit there with the goggles on and just watch. You can interact with the wand and everything else. Is it still like that? Is that still one of your key differentiators, I guess you could call it? Is that, you can interact with the wand and all that sort of jazz?
Yeah, so the major components that we have is the headset, which has the projectors and tracking system. We have a content hub that has our main CPU, our battery, Wi-Fi, all the hot and heavy stuff. So we keep that away from your face. And then we also have the game board, which has the magical retroreflective material that makes it all possible. And the wand is like our game controller, but it also has tracking markers on it, so we can track it in 3D space. And that's one of the major ways that you interact with the system.
Right.
And so all the features and examples that were shown in the Kickstarter videos, we're still intending to hit most of that. The technical details of how we actually accomplish that will be changing. So I know we talked about like the RFID grid.
Yep.
We're not going to be using the RFID in the future. We have other methods that are more integrated with our existing tracking systems.
Got it.
So what is your role there, Jason? Tell us about that.
Yeah, well, I think my business card says hardware engineer right now. And as we've been growing,
man, if you're on the amp hour.
Yeah, definitely.
No, this software rubbish.
You do accept
I mostly
firmware
do,
sometimes.
Yeah, I do firmware when I have to.
Right.
And most of the time I'm doing electrical engineering. And we actually just hired another electrical engineer, so it's been great to have a little bit of relief there. It's given us a great opportunity to spend a lot more effort figuring out the details of the design and make sure we actually have a product and not a prototype.
Gotcha. Yeah, like take it to actual production, stuff like that.
Yeah, it's like that. The last 20% of the design effort, that's like 80% of the work.
Yeah, right.
Yeah, we're in that stage right now.
Yeah,
great.
Are you guys like working with manufacturers at this point? I mean, again, whatever you could talk about, but like, are you doing like the larger scale type stuff?
Yeah. We've done. I think we've built somewhere on the order of hundreds of prototypes so far. We're partnering with someone in China. And for the glasses, we're taking on most of the responsibility for the design. The hub and the wand are pretty much like a cell phone without the screen and a game controller with a couple extra things. So those were pushing more of the design effort onto our partner because they're relatively simple. And then that allows us to focus our limited resources on the glasses, which is really the
magic part, right?
Key part.
Yeah, that's good. I mean, and then especially like if you're trying to target lower costs. I mean, you guys are trying to target low cost BOM costs, right?
Yeah, I think the key phrase I'm allowed to say is we're trying to hit a price point that's on par with a modern console.
Oh, that's higher than I thought. So what, like $300-400 kind of thing? I don't actually buy consoles anymore.
That's
I guess
typically the psychological impulse buy point is like sub $400.
Yeah, we're trying to create something that almost anybody can get access to and have fun with our system.
Yeah.
And of course, it plays into the business models and so forth.
Yep. Yeah, if you're working with an industry that people understand and games and stuff like that. Yeah, it looks like I actually have not seen. I've been not paying attention to the Switch thing at all, but $300 ish looks like. So that's cool. Yeah, that's great, man. So. I mean, technology has been changing over time. I remember when we've heard about it, it was a lot of FPGAs and not DLP drivers, but there were like those projector drivers and stuff, right? Yeah,
we're using LCOS panels and a Pico projector that we've custom designed.
Cool.
Nice.
That's great. Is that like working from reference designs and stuff? Like just kind of customizing from there?
Yeah, I'm not too familiar with the optical design. We have a great optical engineer here that's been managing that for the last over a year now. And we have some advantages over most projector designs because our light output is somewhere around a lumen, like that order of magnitude.
Yeah.
And that's much, much less than most projectors are.
Yeah.
And because we have the retroreflective surface, so all that light, or like 99.9% of that light, comes right back at the user's eyes. So we don't actually need to be too terribly bright, and that gives us a huge advantage for, battery life, the design of the projectors, so forth.
Yeah. Right, no huge fans on the face.
No, big fans to cool your head down.
Yeah.
As we... The thing I've been noticed about the Cast AR is that there's so much little technical detail that could almost become a showstopper. And you've got to overcome all these little hurdles, otherwise it's game over, man. Game over, man. And have there been any stuff like that you've worked on, or was that all sorted out like right at the beginning by Jerry and the early cohorts?
I think a lot of that was sorted out pretty early. I'd actually disagree that the system's pretty brittle. And the way that I've seen it, we have all these, we have multiple ways of doing a lot of the things that we want to do.
Okay. Yep.
And I've seen a lot of like corrections that techniques that we have to correct for head movement and so forth. And we have multiple different paths, and every demo that I've seen where we enabled just that one thing makes it a magical experience.
Right.
And so I'm really excited when we turn on all of these things all at once.
Right.
And it'll be that much better.
So you're talking about like sensor fusion type stuff is almost, or what do you mean by that? Like the corrections?
Yeah, so sensor fusion is going to be part of it. We can do some prediction as well because your head can't accelerate that far. That fast. Yeah, there's limits.
Challenge accepted.
Yeah, and because we've constrained the design space, it really relaxes a lot of the other design constraints. We're not trying to do room scale tracking just yet with this version.
Right. Yeah.
So we just focus on the game board right now, and then that simplifies the problem quite a bit. Like we always know we're going to have those tracking markers, because if you can't see the tracking markers in the game board, you can't see the game board and you can't see the retroreflective surface. So it doesn't matter that much if we lose tracking in that scenario.
Got it.
So it's little things like that that are going to help make the system very feasible.
So all the elements really haven't come together yet in a complete package. You've sort of like, maybe a few of them have, but it sounds like you haven't actually got the complete package together yet as a whole.
We have the whole system running end to end right now. Yeah, with the latest prototypes for the hub and the glasses. What hasn't come together is all of the enhancements that we've been making.
You got it. Yeah.
Yeah.
Right.
So when those come online, the holograms will appear sluggish right now, but when the enhancements come online, they really appear to be locked to the table. And there's this certain threshold that's a little hard to describe, but once it gets good enough, your brain locks in on it and just treats it like a physical object. It might as well be a physical object.
It's kind of like, what's that magic response rate, like at 0.3 of a second or something, and anything under that appears instantaneous, but anything slightly over that.
Yeah, 30 milliseconds. It's like human perception.
30 milliseconds, the human perception. Anything slightly over that, and it appears, oh, geez, that's a bit sluggish. Your brain just sort of switches modes kind of thing.
Right, yeah.
Well, and there's also like the averaging of like LEDs and blinking and stuff like that too, right?
Don't know exactly what you mean by that.
So like that same, I think that same number also works with like if you're pulsing an LED, you can't actually see the individual pulse if it's below 30 milliseconds, like stuff, that kind of.
Oh yeah, like persistence of vision displays and that sort of thing.
That's the right word. Yeah.
That's what he was after. That's what he was fishing for.
Got it.
All right.
Yeah, so the human eye is actually not that quick, at least compared to the audio, like your ears. Your audio channel into your brain's pretty low latency, and your eyes are pretty sluggish in comparison.
Right. Well, because there has to be a lot of the process, like it flips the image and it sub-processes it before it goes in or something. There's lots of stuff that happens there visually. There's
like the V1 and V2, I think they're called. It's been a while since I took that class on the human vision system, but
there's a class on human vision systems. Sorry, I just have to know this. What did I miss at uni? Like,
well, there was one when I went to college. Yeah.
Really? As part of what course?
It was actually an elective, and it was taught by Professor Christoph Koch. and he's
Where'd you go to school, Jason?
I went to Caltech for undergrad.
Oh, cool. Okay.
Yeah.
In engineering, I assume.
Yeah, actually, mechanical engineering.
Right.
So yeah, and then was getting interested in control systems and that sort of thing, which involved writing computer algorithms and firmware, and then eventually soldering up robots and that sort of thing. And that's how I got involved with electrical engineering.
And that was the beginning of the end.
Yep.
Yeah. That's cool, man. So you guys hang out at a playground all day, right?
Yeah, Playground Global. It's Andy Rubin's new VC firm.
Well, not that new, is it?
So
not that new anymore.
So that's where the company's based?
Yeah, we're based right here. So part of the deal with Playground is we get the money, but we also get a space to set up shop.
Right.
We got all of our engineering staff here. And then probably the coolest thing about it is there's also engineers hired by Playground that work for Playground and consult.
They can consult for any of the portfolio companies. Right. That's interesting.
And you guys have a sweet shop there too. I mean, that's nice.
Yeah, we have a really nice machine shop, and we just got a 5-axis, I think it is, mill that can make injection molding tools. We have a 3D printer that can print directly in titanium. Obviously,
totally
necessary.
Necessary. The titanium thing. Yep.
Yeah, we haven't quite found a use for that yet.
Trinkets. all of our field pieces are titanium printed. Each one costs $400,000 each. That's cool. So what else? I mean, I got to visit once, and that was very nice of you to invite me there, and I appreciated that. It seemed like I won't say like a clubhouse, but there are other like hardware companies there too, which is cool.
Yeah, there's a bunch of portfolio companies here involved in all sorts of different markets, but the one unifying thing is they're all hardware companies, and that's probably the distinguishing feature of the Playground investment firm.
Yeah.
So is the idea that getting all these hardware companies together, do you all like hang out in the same canteen and mingle at lunchtime, or do you get into your own tribal groups and and you have food fights with the other hardware companies, or does it, is that the idea, is to get like mixed hardware companies to mingle together? Is that part of the concept?
Yeah, I'd say that's part of it. We do hang out together, like Chris was saying, at happy hour.
Right.
Friday afternoons. That's probably the best opportunity to mingle across companies.
Right.
During the week, though, we're pretty focused on our own work. But we have had a few times where, because we're consulting with the Playground engineers, they see all the engineering that's happening across all the portfolio companies.
So they're the ones you want to hang out with at happy hour, so you can talk to them to find out all the secrets the other companies doing. That's the.
I was really surprised, or not really surprised. I think that, I really loved visiting there, and it was really nice. I got to show up at a happy hour. That was great. But I'm always surprised when people don't talk about the projects. Like I met someone there, and they're like, "Oh yeah, well we're in stealth mode." I'm like, who the hell cares?
Most engineers
will never
don't
understand
care about that. Most engineers just want to talk about their shit. They don't.
Right.
I'm surprised. Were you hanging out with real engineers? I mean, usually they're
they seem
as
legit
loose-lippy as you get.
Right. I mean, Jason, do you hear about that there? I mean, are there people that are like pretty tight-lipped about stuff, or what?
There's definitely some of that around here. I can kind of see some of the benefits of keeping things close to the vest, but in general, I haven't really found a good reason for being in stealth mode, as it were.
Yeah. Right.
Well, I mean, you're working on these glasses, and you understand all the supply chain stuff and all the other difficulties, and it's like, not to mention that, like, when you're doing hardware, you're going to have to get your bomb coated at some point, right? It's like, it's getting out of the world somewhere, It's like, yes, there are secrets, and yes, there are things that you should, definitely not talk about, and I'm sure Jason will not tell us things if we asked him, but, like, but, like, even the idea, like, oh, you're working on a drone thing? Ooh. I don't know. I start getting antsy when people do that.
Yeah, it's kind of a conversation ender.
Right.
When you ask, like, hey, what are you working on? It's, I'm at an aerospace stealth startup. It's like, okay.
Big gulps, huh? All right. Well, see you later.
I think they're more likely to fail than not, because they think they're onto something so disruptive that their odds of success are probably lower. I'm probably generalizing here.
Yeah,
but you know.
No, I think I agree with you. And Cast AR, I like what you guys are doing because I understand it. Obviously, we've seen details, but
with what they're Cast AR, pretty open with what they're doing.
But then compared, what's the other one? Magic Leap, is that the other one?
Yeah, that's the big AR company in this space.
Right, and that's been a hype machine for 5 years. And yes, investors have seen it, but they're also hype machines. And it's like no one's seen a real thing. No one knows if it actually exists. And it's like, I don't, people want to talk about it. It's like, just fine, but show me a real thing, like hardware talks, that's, I don't, oof.
Sounds like Ubeam. Anyway, no, so you would agree that these companies are probably, just from a sheer statistics point of view, more likely to fail? I'm talking to Chris here.
A lot of startups at that stage are pretty likely to fail.
Right.
But I just, that's the sense I get, is that if you're in stealth mode, it's like, you're probably more full of crap than someone who's not in stealth mode.
That's
okay, I'll
quite the
stop
assertion, Dave. Yeah.
All right.
Anyways, so Jason, anything else we should know about Playground?
No, I think we pretty much covered everything.
Cool.
Although stick around for the end of the show because he's going to tell us how you can work there too.
Oh, yeah. Well, let's talk a little bit about Reclaimer, because this is your other thing. This is the real thing that so obviously I get to see you every month. You are very diligent in driving up to, or taking the train up to the meetup that I do in San Francisco all the time. But you've been working on Reclaimer as like your personal brand. What is Reclaimer?
Yeah, I think personal brand's probably the best way to put it. It's basically all the hobby projects that I work on. If they're going up on Tindy or something like that, I just kind of put it under that umbrella. And I have a bunch of pretty interesting and diverse projects right now that I'm working on.
Well, let's hear about some of them. Well, wait, leave the newest thing for last, because we'll definitely talk about that for a while.
Okay, yeah. So one thing that I was getting into was LEDs, and I actually gave a talk at one of the San Francisco meetups on LED driver circuitry. And I have a product right now that I'm putting together that's involves over 25,000 LEDs.
What? Mike Harrison, eat your heart out.
Yeah, so it's basically a small segment of like a video billboard that you'd see up on the highway or Times Square. Mm-hmm. And so I took a small section of that and hooked it up to a Wi-Fi connected microcontroller. And you can program it over the internet, and it can connect to websites and pull information and display whatever you want. So I've set up mine so that it's counting down to the next rocket launch, whenever that is.
Nice. Wait, but you said 25,000 LEDs?
Yeah, so it's 128 pixels wide by 64 pixels tall.
You don't need many. You don't need many pixels to
in
a square grid for them to add up.
Yeah,
it's
multiplication, quick. Chris.
Right.
That thing you learnt about in in primary school.
Yeah, so 128 by 64 doesn't sound that great, but that's why I usually lead with the 25,000 LEDs.
Yeah.
What's the size of it, of that panel?
It's about the size of 2 sheets of paper, so maybe about 2 feet wide and about a foot tall.
Oh, okay, so still pretty spaced out though.
Yeah, it's a 3 millimeter pitch.
Okay.
One of the smaller pitches, and these are little panels that you can buy on AliExpress or Alibaba. Adafruit sells them as well in various pitches. Mm-hmm. And so what I did to address all these LEDs, the panels themselves come with a shift register interface. And so I programmed up a CPLD to convert a SPI packet from the microcontroller into this parallel shift register interface that the panels use. Mm-hmm. And then that way I can just do a DMA transfer from the microcontroller out over SPI and then leave most of the CPU time available for doing whatever else you want to do.
Wait, so are you building the panels itself? Are you sourcing the panels and then building the drivers, or how does this all work?
Yeah, I'm sourcing the panels, and then I just design a little backpack board that manages the power and the data. And then the core of it right now is a Protocol Photon.
Oh, cool.
Which I think you guys have probably talked about before.
Yeah, we've talked about it. Yep.
Yeah. And so just using the Protocol IDE for now. and using some of the libraries that other people have written and contributed.
What is? I see another mic. Is there another micro on board, or is that a driver on the upper right of this thing? Where the power comes in, is that just a switcher, or is it like a P-sock or something? I can't quite see the details.
Yeah, so the only other ICs on the design right now are going to be the CPLD and
that's probably it. Yeah.
Yeah, and then I've also had to add in a buck converter. This thing requires quite a bit of power, and it runs at 5 volts. So that winds up being about 16 amps if you turn on all the LEDs.
Okay. So, yeah. So you got like a laptop power supply or something like that?
Yeah, I found a 24-volt power supply, and then I have an onboard buck that'll take that down to 5 volt, and then that way the connector doesn't melt on me.
Oh, right.
That's often easier to do, like a higher voltage input, like a 24-volt input, and then local regulation at the points required is often a good way to do these large distributed projects.
Are you doing 16? You're not delivering 16 amps though. You're multiplexing or something. How do you deal with that?
Yeah. So the 16 amps is with multiplexing.
Oh.
So
but that's total. So you wouldn't it's not like you feed in like 3.3 volts to the entire thing, because then you need to run the high current. That's why I was saying, have local regulation across the board, so you don't have to run.
Wait, but how many buck converters are on board?
Right across to the other side of the panel or something like that. So
yeah, no, there's just the 1 buck converter on my board, and then I think the panels themselves have the shift register.
They've got their own local.
ICs have they're an open drain, constant current.
Yep.
Setup, so they just burn whatever the extra voltage is off as heat. So like a linear regulator.
Got it.
Wait, but I'm sorry, I'm still confused here. So what, you're switching supply. Your buck converter goes 24 to 5 at 16 amps.
Yeah, 5 volt, 16 amps out.
What's the efficiency on that thing?
According to the calculation, somewhere around 95%. I'm getting the prototypes in soon, so I'll be able to really calculate that.
So like 75 watts. Oh, I guess okay. So like 1/20th of 75 watts. Is that right?
I think it's a little bit closer, like 140 watts.
Wait, 16 amps is on the 24 side or is on the 5 volt side?
On the 5 volt side.
Chris is getting bogged down in the details.
My math is just... Sorry, yeah. 15 times... Isn't 15 times 5? Am I doing that wrong? 15 times 5 is 75, right? So that's where I got that
Yeah,
number
I
from.
guess, yeah, somewhere around there.
Okay.
Yeah, when I had a 5 volt 10 amp supply, that turned out not to be enough.
Yeah.
If you actually turn on all the LEDs at the same time.
Yeah.
So when I say turning all the LEDs on at the same time, like you said, it is multiplexing, and it turns on 1/16 of the LEDs at any given time.
Yeah.
But still, it's cycling through that. There's enough LEDs in a row to draw a lot of power.
Yeah. That's crazy. Okay. So yeah, but the calculation that's not bad though. That's only burning 4 watts then. So if it's 75 watts out at 95%, it's only 4 watts. So that's not bad.
Yeah, it's still pretty significant for a buck converter.
Yeah.
That's more along the lines of what you'd expect to dissipate with a linear regulator in most other projects.
You actually need a reasonable heatsink on that, or airflow.
Yeah, I had some heat sinks that I found that are SMT compatible, and they're kind of shaped like two T's butted together, so they only contact the board at 2 points, and you solder them down, and it gives me a lot of flexibility.
They're very cool. They can go over the package. They can go over like TO220 type SMD packages and stuff. So
right, yeah.
Sorry, TO220 is the through hole. I'm talking about D squared packs.
Oh. Right, yeah. So I think, so obviously I'm using a buck controller, I think it's called, not a regulator, technically. And then...
right, because you mean external MOSFETs. That's what you mean.
Yeah, and for the 2 FETs that you need for a buck converter, I found this part from TI that has both of them in one package. And... so they're connected, the source of one's connected to the drain of the other, and you just get the gate for the high and the low, and helps with the layout, and also helps with the efficiency because you get less losses between the two FETs.
Yeah, because they're matched. So.
Right. Yeah.
That's cool. So you're gonna start selling this thing soon, though?
Yeah. So we'll see how the testing goes for this prototype. I got ordered 2 boards from Macrofab, and they just shipped the other day, so I should get them this week. And if the testing looks good, I'll order a few more, and then I have a custom designed frame, and the whole thing screws together pretty easily, so I should be able to get a bunch of them up on Tindy and get to do some documentation and that sort of thing as well. But yeah, next couple of weeks or so is the plan.
Cool, man.
Sweet.
That's great. Sounds like Cast AR must be easy, huh?
Well, I've been working on this for probably over a year.
Yeah,
definitely.
Okay.
Yeah, nights and weekends when I can.
Nerd.
Yeah.
Best kinds. So what else you got? You have another one. You have the thermocouple thing. You sent me, or you showed me one of these, or you sent one with your friend.
Yeah. So this is kind of a weekend project that I did for a friend of mine. He's finishing up his PhD in material science in Chicago.
Woo, Chicago.
Yeah. And he's was telling me about some of the work that he's doing in the lab. And when I visited with him, he was showing me around. And we were both talking about how manual this process is. And it's, for the most part, the material science research hasn't really advanced much beyond the 1890s. So one of the things that they do is they have these furnaces, and they will anneal samples for a while, like 3 months at a time.
Yep.
And they need to maintain a constant temperature for that entire time. The problem is with the lab infrastructure that they lose power on average about once a month. And even if it's only for a couple of minutes, it's enough to reset the furnaces. And so somebody's got to go in there and push a button, turn the furnace back on.
Right.
And
right.
The thing's so massive, you don't lose that much heat.
Yeah, the thermal mass of it.
Yeah, so if you get it quickly, it's fine. So anytime they get an email that powers down in that region of campus, they have to go down and physically check on it. And look at the digital readout on the furnace. And so with this device, they can just hook up a thermocouple, and it might not be good enough to collect scientific data, at least not yet, but they can at least get an idea of if the furnace is still on. And if it is, then they don't need to go in, like on Thanksgiving, where my buddy had to walk 30 minutes in the cold into the lab. And just to find out the furnaces were fine, and then turn right around and go home.
Sounds like we found it, Dave. I think we
sounds
found
like a job for the Internet of Things.
I was gonna say this is the first practical version. I think we may have said that in the past, but this is the somewhat practical thing. It seems like.
Yeah, I also call it the Internet of Thermocouples.
Okay.
But yeah, this was a project. I thought about it, and it's like, this is like a weekend project. Basically one day to design the board, and then spend about another day writing up the firmware libraries. And it's all open source, and I just got the product approved on Tindy as well. So I made a couple extra, and they're available for sale if you happen to need one.
Cool. We'll put a Tindy link in there, of course.
Yeah, great.
Yeah.
Speaking of stuff getting hot, why did you make a USB-C Easy Bake Oven? Because you can?
Yeah, more or less. I was thinking about what you could do with 100 watts of power, which is the maximum power that you can transmit over USB-C.
Yep.
And so I was kind of thinking, what else is around 100 watts? And
light bulb.
I thought, what a light bulb.
Yep.
And
not anymore, man. You can't even get those anymore, right?
Well, I would not have guessed an Easy Bake Oven. I would have said that's 1,000 watts. Like, aren't ovens like order of magnitude more than 100 watts? I mean,
no, Dave.
I don't know. I don't use Easy Bake Ovens, I guess.
Yeah, well, the original Easy Bake Oven just had a 100-watt incandescent bulb.
Yeah.
And that
Oh,
was
did
the,
it? Okay,
the
right.
heat source.
Right. I didn't
That's
know.
why it was so
Right.
cheap, and it was a toy. I mean, like, yeah.
Ah, right.
Yeah.
Yeah, and it was considered safe for kids, even though it got up to
okay.
350
Right.
degrees Fahrenheit.
This is an
Really?
American
Oh,
thing. I don't. Right.
Yeah.
Yeah, I mean, it can bake cookies. I mean, it's a really
Right.
small chamber, so that's how it gets the power down. But,
Got it. Yep.
Yeah, when I did the final tests on my modified oven, I measured it with the thermocouple, and I was reading somewhere around 300 Fahrenheit, which is a little low for an oven, but it was hot enough. Leave the cookies in there a little bit longer than usual, and they
great
bake
for a
just
sous
fine.
vide, right? I mean, you could do a sous vide in there, no problem.
Yeah, I could actually probably do a little computer control.
Yeah,
and target a specific temperature.
Make some delicious steak.
Then you get into PID control and fun.
Yeah, I already did that for a smoker that I built.
Nice.
Right. So I have not worked on USB-C. I don't have anything that uses USB-C.
It's pretty new, right? I mean,
yeah, it's pretty new. Yeah, I'm just working on all of my computer shit's like 5 years old. Is there an issue with, because there has been with like USB 3 and stuff like that, was with that, like if you buy the cheap shit USB cables, they're just rubbish. They've got no copper in them. I can't imagine, like the USB-C cables that are supposed to deliver 100 watts, and then you buy the cheap ones for $2 on eBay, and they're going to deliver. Have you had any issues with dodgy USB-C cables yet?
Well, like you said, the standard is pretty new, so the market hasn't really yet been flooded with all the low-cost knockoffs. I'm sure that's coming. One thing that's in the spec actually for this high power is if you're going to draw over 3 amps, the cable itself has to be what's called electronically marked, which means there's a microcontroller in the plug of the cable that responds to a certain packet.
They'll fake that as well. And then to get the cost down, they'll put 1/10 the amount of copper in the cable, and they'll fake the ID. That it's going to happen.
Yeah, I mean, yeah. Obviously, it'll happen, and hopefully, there's I forget his name, but that Google engineer on Amazon that goes around reviewing all the USB-C cables.
Oh yeah.
So hopefully, the online reviews and so forth.
I haven't heard about this. Does he? Is he so, passionate about USB cables that he goes around and tests all the cheapies? And
well, he's been working on USB-C at Google, I'm pretty sure.
Right.
And so just kind of as a hobby, he buys one of every cable on Amazon and plugs it into his little USB-C debugger and finds out if they're connected.
Right.
There's certain pull-ups and so forth that can get connected. Like if you pull it up to VBus, which you assume is 5 volts all the time, when you set up VBus to be 20 volts, you can start frying input pins on your microcontrollers and that sort of thing.
Goodness.
So Jason, you wrote a series of posts. We've been posting your posts to the subreddit and mentioning them here once in a while. But you wrote a series of posts. Can you kind of just give us a rundown of how you got started in USB-C, but also kind of what it involves and the challenges you've seen with it?
Yeah, I got started with USB-C actually with CastAR. This was pre-Series A days. We're trying to figure out how we're going to design a product that can carry the video and so forth with a removable cable. So you can unplug the two devices. Until then, we had just sort of hardwired them and connected them internally with a connector that's good for, say, 10 or 30 cycles.
Right.
And we wanted something that the user could unplug and plug in every day.
Kids, oh my God, slam those cables together, wham!
Yeah, so we were looking around some off-the-shelf connectors like HDMI and DisplayPort, and was interested. It was interesting to figure out that a lot of them are only rated for about 300 cycles.
Yeah, which is not many if the consumer's whacking them together.
Right, so once a day, 300 cycles is less than a year, and we definitely want our product to last more than that.
Is that just because of the gold contacts, like the gold plating and stuff, or is it something else?
Yeah, I'm not exactly sure.
There's a whole bunch of mechanical the wear. If you insert them at a not optimal angle and stuff like that, it can wear out part of the connector. Then it just gets worse and worse. And there's a whole bunch of standards for testing connectors in this sort of way.
Yeah, and especially when you want to run DisplayPort over the connector like we have, you can wind up with signal integrity degrading over time.
Oh, okay.
So one of the connectors I was looking at that had a really high cycle life was the Micro B USB connector. And that's rated for something like 10,000 cycles.
It's nuts.
And so
a lot of people claim that's bullshit, and it doesn't take into account angled connections when you plug it in at an slight angle constantly, and all that sort of stuff.
Yeah, but anyway, even if it actually was 1,000, that's
it'd still be pretty good.
About 3 years,
exactly.
That's probably good enough. And then I came across USB-C, which was really new at the time. This is like 2 years ago that I was looking at this. And it seemed to have everything that we wanted. You could run video over the super speed pins by going into an alternate mode. We could provide enough power because your power rating, even staying at 5 volt, you can get up to 15 watts.
Wow.
And and on top of that, we could also do the USB 2 high-speed communication. We can do all these things over one cable, one connector, and the cycle ratings, at least on the data sheets, were 10,000 cycles, like Micro B.
Yep.
And it's reversible. One of my favorite things about it.
Yeah, that's been a little bit of a pain to deal with.
Yeah, right. Why is that? Yeah.
Well, because your power connections are backward, Chris.
Actually, it's not the power.
It's not.
So the power pins, there's just four power pins and 4 ground pins. So they're radially symmetric. It doesn't matter which way you plug it in.
Okay.
It's the super speed pairs. So the USB 2 is slow enough you can just short the 2 options together. So either way you wind up with the positive and negative connected. But with the super speed pairs, if you're at gigabits per second, you can't just short them together because you'll have a huge stub. That'll ruin your signal integrity.
And what is the speed of that? I mean, is it like 5 gig or something?
The connector, I believe, is rated to 10 gigabit per second, depending on which specific model connector you're getting. Mm-hmm. But the maximum in the spec is 10 gigabit per second per lane, and there's 4 lanes.
Oh, wow.
Sweet.
Yeah.
Yeah. So you can run, theoretically, 40 gigabits per second of data and 100 watts all at the same time.
That's just a lot of stuff going on,
Yeah. So unlike traditional USB, which is 4, maybe 5 pins, this one has 24 pins.
Yeah.
And some of those are redundant, like I said, for the power. And then there's actually a dedicated configuration channel that's used to determine the orientation of the plug, and a connector power source. And there's a lot going on.
Right. So it enables flipping and all this stuff, but at the expense of like brokering who's the master, who's the slave type stuff, or how does it actually do that handshaking?
Yeah, all that handshaking is done over the communication channel. And the very basic way to do it is just with some pull-ups and pull-downs, and you just do some analog reads or you set some analog voltages. And then if you want to do more complicated things like swapping power roles or swapping data roles on the fly, you need to do what's called the power delivery communication. And it's called power delivery, but it does a lot more than just power. And that's right now the only way to do it is with biphase mark coding, I think is what the acronym's for. It's a BMC communication. It's a one-wire protocol that's all time-based. And until recently, you kind of had to do some tricks with some SPI hardware to get it to work. But now there's a bunch of PHYs on the market that just convert that to something like I2C that's a lot easier to
that's nice. So it
plug
just
into your Arduino.
Abstracts that out kind of thing.
Yeah.
That's good. That's great. Yeah, I was really confused. So I've been looking at the new MacBooks too, where they have like 4 ports on board. And I was thinking like, well, what if you plug 2 chargers in? Or like all of that stuff where it's like you got to kind of, like there's 4 USB-C ports or whatever they call it. I don't know. But it just seems like there's a lot of who's in charge here, who's sending what, who's receiving, like all that stuff. It seems like there's a lot of handshaking that needs to happen in order to not blow things up.
Yeah, and I think that's one of the biggest risks with USB-C because you can put everything on one connector. You could have a connector do anything. So your laptop might have only one of the 4 ports you can actually charge the battery with. And you better have the charger plugged into that port. Or you might have multiple ports, but only one of them can do video out. And so you need to make sure you plug your monitor into that port and not any of the other ones. Mm-hmm. And to get around this, there's this series of markings that you can put on the case, which the user will probably ignore. And then there's also this new standard that they've created called a USB billboard class. And what that's supposed to be able to do is deliver over USB a human readable string that can let the user know why it's not working.
You're breaking it. You're breaking it.
Yeah. So, theoretically, you could plug your monitor into the ROM port, and then the computer could send a message to the monitor, and the monitor could display a message that says, like, hey, you plug this into the ROM port, try port number 1 or port number 2.
Dummy. Yeah.
Yeah. So it'll be interesting to see how that problem is resolved. Obviously, the best solution for the user would be just make every port able to do everything. Mm-hmm. But now you're talking about a lot of extra hardware internally.
Right, because then you have to like broker that at some point on the circuit board and still do it relatively quickly and have all the power and signal integrity stuff pass all the way through, right?
Right, yeah. So you have to add switches and muxes internally, which you already have to do right now in certain circumstances for monitoring the cable flip. But that's kind of been the general strategy behind USB-C is make things easier for the user and push all that effort back on the engineers.
Yeah. What about the so so it doesn't start delivering. What does it take to get to the 100-watt standpoint? So you said there's some kind of electronically mark in the cable, but like, so can you walk us through the steps to kind of to get to 100 watts?
Sure. So the first thing is the source will be powered up because it's providing the power. So it's monitoring both of the CC lines. There's CC1 and CC2, and it'll activate pull-ups on those lines. And so when it sees the voltage drop on one of them, it knows that number one plug has been inserted, and also it'll figure out which position the cable's in, which of the two, in normal or flipped orientation. And then at that point, it can provide 5 volts to VBus, which is just like you'd expect from USB, pretty standard. And then the source, because it can do 100 watts, it has to send out these source capabilities messages that are just unsolicited. So every couple of seconds, I think it is, it'll just send out a packet and it says, hey, I'm a charger. I can do 5 volts at this current, and then it'll list, after that, it can list all the other voltages and current limits that it has. The device on the other end, so in this example, it's the Arduino that I plugged into my breakout board. So it's either waiting for those packets to come through over power delivery, or it will send out a source request packet. So it asks the source, hey, what are your capabilities? And then once it gets that packet, it can go through the capabilities, and the code that I have right now basically looks for the highest voltage, and then in that just grabs the highest amount of power that it can. And I just program my code as like anything up to 100 watts, go for it.
Nice.
So it'll see the 20 volts, and I think it's 89 watts, so it's like 3.6 amps or something like that.
Uh-huh.
So it'll see that, and I'll say, okay, I want that index, index 2 in this case. So it'll send back a request message with that, and then it's up to the source then to grant that request. And what can make things a little bit complicated, in this case, it's really simple with the Easy Bake Oven because I'm just using a MacBook Pro charger, so it only has the one USB-C port. But you could have a hub that could be supplying power to a whole bunch of different devices. So it has to keep track of what's its total input power and then how much has it promised.
I was going to say a hub, you'd need if it's got 10 ports, you'd need, in theory, a kilowatt if you wanted to supply full power to each one.
Oh, wow. Yeah. That'd be intense. Yeah.
It's insane.
Not to mention efficiencies of each, well, is it just doing pass-through at that point? I mean, like, there's probably switching on board then, too, right? So you have efficiency losses and whatever.
Yeah, I haven't really seen a teardown for the new MacBook Pro chargers, but yeah, I assume there's some sort of a buck or similar switching converter in there. So anyway, it gets the source gets the request, and then it will do all these calculations and figure out if it can actually fulfill the request. And in this case, I know that it can because I'm the only device plugged into it. So it'll send back an accept packet. And it basically says like, yep, that's good. Let's do it. And then I'm still doing a little bit more research into exactly how it works with the electronically marked cable, but it's up to the source basically to interrogate the cable as well using a different header. And it asks the cable, like, hey, what are your capabilities? And before it actually provides the power, it needs to verify that the cable has the capability to transmit up to 5 amps or whatever it is.
Have you had to like experiment to find out this stuff, or is it all documented, or is it like a closed standard that you have to pay to, get the standards document to figure all this out, or what?
So all the basic USB stuff is available on the USB website. Mm-hmm. You just go to the developers page and you download the zip file.
Got it.
Yeah, some of the more specific stuff, so the alternate modes, how to use those, that can be proprietary. So,
okay. Right.
So for example, getting into an alternate mode, that's in the USB spec, but the alternate mode for DisplayPort, for example, that's run by Vesa. I think that's how it's pronounced.
Visa is how I pronounce
Visa,
it.
Vesa, VESA.
Yeah.
And they publish a spec. They publish the DisplayPort spec, but they also publish a DisplayPort over USB-C spec, and that you have to be a member of their club to get access to the documentation.
It's really cheap to be a member too, right?
Yeah, I'm sure.
Yeah, I think it's like $5,000.
Yeah, that's actually cheaper than I would have guessed. Okay.
All right.
Yeah. And sometimes you can find bootleg copies on Baidu or something like that. But
no,
to get the real spec, you have to pay the fee and become a member.
Yeah. Well, no, like if you were making cables or whatever, if you wanted to market as compliant too, I'm sure you'd have to pay licensing for that, right?
Yeah, if you want to put the logo on your product and tell people that you're a DisplayPort device, they own all the trademarks, so that's basically what you're paying for is a license to use their trademark. There's also I'm aware of HDMI and a few other standards that are becoming pretty popular for as alternate modes for USB-C.
That's great. Yeah, I think that. I was excited when they came out just for the power stuff, but this other stuff, honestly, the fact that Google and Apple kind of co-developed it, they were like part of it too, and like. I don't know if people saw the iPhone 8 is rumored to be switching to USB-C and everything. Like, I just think it's... I thought it was such a great move when the European Union standardized on USB micro. And then, thinking about this kind of thing, like taking it now a step further, like, it is kind of a one cable to rule them all. And obviously, there's a lot of challenges like you're talking about here, but kind of the idea of, like, it's... definitely more of a universal cable than a lot of things that are out there. So
but
I really
USB,
like that.
micro USB is still going to survive because it's micro. It's much smaller. Like you can put it in tiny little products and stuff like that.
Well, actually, the USB-C is not that much bigger than
it's
a
not,
micro
it's not
USB
a huge
connector.
amount. I've never physically seen one. It's not that much bigger?
Yeah, it's much less than twice the area, I would say. It's like just a little bit taller and a little bit wider.
Yeah.
Right.
More board space for the Phi chip and stuff like that, right? All the handling and whatever.
Yeah, and there's actually a lot of options on that side. So there are microcontrollers that you can buy that just have an M0 and the Phi and all the hardware that you need in probably like a 2x2 millimeter package. There's FPGAs, I think, that I've seen that have been incorporating some of this hardware.
Okay. Interesting.
TI, I know, has a lot of integrated products. So they'll integrate the BMC Phi, the muxes, and maybe even a USB high-speed to serial converter all in one chip. And so there's a lot of options out there. The stuff that I've been working with, I prefer to do more of a piecemeal solution, which is great for prototyping. So I've been using a Fairchild part.
Is that FUSB 302 that you have a board for?
Yeah, so another Tindy link to put in the show notes.
Yeah.
I have a little breakout board that basically breaks the pins of this Phi out to headers, and that's what I used for the USB-C Easy Bake Oven. just jump right over to an Arduino. And then, if you want to talk about complexity, the code to get all this running, I was porting a library that Google Chrome has for their embedded computing. And I sort of lost count of the number of lines, somewhere around 4,000.
Good Lord.
And
4,000 on an Arduino? Is that right? Or
yeah, well, of course, it only compiles the stuff that it actually needs, but I think it uses like 60 or 70% of the program space right now.
Yeah.
Wow.
Okay.
Just to do the USB-C. So it is possible to run it off an Arduino, but...
Yeah. So in terms of complexity of the... Is it just handling lots and lots of scenarios? Is that kind of the thing, or what?
Yeah, so basically there's a big state machine is kind of the core of it. And it has something like 29 possible states. And the state machine itself is the majority of the code. I think that's like 1,500 to 2,000 lines of code.
Sounds like a job for CPLD.
Yeah, maybe.
That is interesting. So you got up to 300F, which is what? That's like 190 C, is that right? My mathalizer is broken today, but so that's not bad though. I mean, on temperature wise, kilowatts showed 80 watts of power being drawn. It says. And what were you sourcing? You were just sourcing into a heating element, is that right?
Yeah. So first thing I had to do was take apart the oven because I knew they had moved away from the incandescent bulb, so I was kind of curious what they had replaced it with. And it turns out it's just a nichrome wire. So it's just a fancy toaster, basically.
Wait. This is an actual easy bake oven that you're using here? This picture that you of the...
Yeah. I bought one on Amazon.
I didn't know they still made them.
They do. They've had to, like I said, move away from the bulbs, but they have a new design now that uses a nichrome wire. And basically when you flip the switch, it just connects the 120 volts across the nichrome wire.
Safety.
Sorry. but that's what a toaster is. I mean, it's mains across an element. I mean, geez.
Yeah, and this is a lot safer than a toaster because the heating element itself is so far buried. There's no possible way, even with small hands, to get in there and touch it. And you have to use this plastic tool to move the baking tray through the unit. So they've definitely thought about safety and reliability there. So the one thing I had to do, basically the major modification I had to do was chopping up the heating element and dividing it by 6. So I had 6 equal elements and then wired them all up in parallel.
Yeah.
So cut the resistance by a factor of 36, and that winds up being about the same amount of power. I wasn't quite perfect with how I divvied up, so I only got like 75 watts out.
Mm-hmm. Right, because it's just that's going to help determine the load, right? It's only going to ask for so much. Does it? So that's actually an interesting question. So the source and the I've already forgotten the name of these things, but it says
sink.
The sink. Okay, so one of them says I have this much power to offer. The other one says I can accept this much power, right? But in your case, you just have an open load, or not an open load, but just a dumb load, pretty much, right? So how does it handle when it's not the maximum power that it's trying to deliver? Does it deal with that okay?
Yeah, well, it seems to from all the experiments that have been running. But basically when you send the request message, you're sending along a couple of numbers, and I think it's the number in tens of milliamps for 2 currents. So one is your sort of normal operating current, how much you're normally going to use. And then the other is like a surge current or a peak current that indicates the maximum possible that you might need at a certain time. Mm-hmm. And so normally those will just be the same, and it'll be just whatever the sort of average max power you're going to need. And so in this case, my code sets those values to match the maximum that the source is offering. But theoretically, the source could say I have 20 volts and I can do 5 amps, and you could send back like 20 volts sounds great, but I only need 1 amp. And then like we said, for a hub situation or multi-port device,
it takes it away. It takes it away from the power budget. So
yeah, and this gets into terms that USB calls like policy managers and policy engine, maybe. I don't know. There's a lot of fancy buzzwords.
We call it the power bureaucracy. One must handshake with another. Sync must talk to source. Yeah.
A lot of people got that wrong on USB 2. Is it or is it USB 1 or whatever? Like the original, 500 milliamp USB limit. There's a lot of people that claim that you have to communicate to enable the 500 milliamp load, but that was bullshit. You could have just ignored it. All the devices were just capable of providing 500 milliamps anyway. It was like it's only if you wanted to play nice that you would actually request, from Windows, you would request like the power budget, say, I only need 100 milliamps, so you're free to give 400 milliamps to somebody else, or to 4 other devices, for example. But you could just ignore it. It wasn't an enforced thing.
Yeah, that's what happened in practice. And I think some of that was just, it was not worth the complication of trying to figure out how to kick devices off. So it was easier to just wire everything to the 5-volt rail.
Yeah, that's it. And in most ports, it have a 500 milliamp fuse on there anyway.
Yeah,
so,
I was going to say, or like an RTD
switch,
or something.
Yeah.
So, an RTD, a PTC.
It was all good.
Yeah.
Yeah. I found more so than with the USB 2. With USB-C, I've definitely gotten kicked off buses for sending malformed packets and so forth. Like, the circuits are complicated enough that it's just a matter of firmware to enforce these sorts of things. So they get enforced a lot more. And it's having a protocol analyzer or something like that has definitely helped, because keep wondering, like, why do I keep getting reset? I keep getting a hard reset. It just turns off VBus on me every time.
Oh, really? Okay. What do you use for that kind of thing?
Well, we have a really nice one at work from Teledyne LaCroix. It's like the Mercury T2C, which is just their T2 model with all USB-C ports. And it'll record and trigger off all sorts of various things happening with power delivery, and can keep track of the pull-ups and pull-downs and what got plugged in where. And then you can pay another fee and then also do
of course you
high-speed
can. It's
USB.
Teledyne LaCroix,
Yeah. I know there's one that Google released and open sourced the design of, and I think you could get it on Amazon last I checked. That one was only like $120.
Okay.
Yeah, it's always been kind of a dream project of mine to put together an open source USB-C protocol analyzer.
Analyzer, yep.
Yeah, it's a lot of work. So
there's a lot of detail in that. Yeah, it's...
Yeah, it's not just hardware. You need firmware. You need software.
Uh-huh.
Yeah.
Mm-hmm. And you're selling into a niche market that,
Right.
Don't really care about the open source thing. All they want is something that works, so.
Yeah, so I'm just starting with just the breakout board and starting with the Google's open source code that I've modified and also made open source. So it's kind of a start, and hopefully other people get involved and can help me with a lot of the firmware.
Yeah. You're on GitHub under what name?
Under Reclaimer Labs.
Okay, cool.
Yeah, so right now I have 2 libraries that I put together. One is just to talk to the PHY, and then the other uses that library and does all the power delivery.
Mm-hmm. Yep, that sounds good. So what was the most surprising thing about USB-C? I mean, like, what should people know if they're getting started into it?
I would say the first thing is that it might seem really complicated, and it can be, but the most basic things that you'd want to do with USB-C, it's pretty simple to get started. So basically you need one extra resistor if you're going to use replace a USB 2 port with a USB-C port. You can just tie the 2 positions for the USB data lines to each other, and then wire that into your device just like normal. Basically, just add a pull-down resistor on the CC lines, and you're good to go. And everything should work just like you expect.
So that's without a PHY, you're saying?
Yeah, no PHY, no extra firmware. You just changing the connector.
Yeah,
out,
using the new thing. So that will give you what? You said that's USB 2.0, 2.1 or something? And
yeah, so that'll give you, just like you expect, the 5 volts, 500 milliamps, USB to high-speed communication, so the 480 megabit communication. And then if you want to get a little bit more power, all you have to do is monitor that CC pin, so that pull down that you added. Just monitor the voltage, and depending which range it's in, that can tell you whether or not you have the 500 milliamps, 1.5 amps, or 3 amps available to you. And again, this is without a PHY. You don't need to do any of the power delivery communication. You basically just need an ADC, which you probably already have on your microcontroller.
Yep.
So that'd be a simple way to get 15 watts in USB 2 communication. And then if you want to go up from there, if you want to do different voltages, connect a battery straight across on VBus, or use any of the alternate modes, then you need to start getting into the 4,000 lines of code and all that.
But to have 15 watts capability, that's a lot.
Yeah, that's nice.
So, that's plenty for most projects, I think.
Yeah, and I think the 7.5 watt version, the 1.5 amp, seems to be kind of the new standard. Like, 1.5 amp is the new 500 milliamp.
Right.
The new hotness.
Cool.
Yeah, the MacBook that I have that has a USB-C port, when I plugged the Arduino into it and read out the capabilities of the port, it was advertising that it could do the 1.5 amps at 5 volts. So that's 7.5 watts from your laptop. So it's
cool.
More than enough to run some pretty interesting widgets.
Definitely. Yeah. Yeah, I had thought in the past that this would be interesting, like especially at the higher voltage stuff, like the 100 watt thing, but like doing some kind of like power supply type thing would be interesting at some point. I talked to some people about that. Obviously you need to clean up the power, but like that is a serious amount of power for, especially for mobile devices and just for most things that you need these days. It seems like it's in the realm of possibility just to use that.
I might use it on my new power supply.
No, there you go.
Yeah, and if you're plugging this device, your power supply, into a laptop, you have USB communication, so you could just open up a USB serial adapter and be running a Python script or something on the laptop and changing the voltage and current limits, measuring things, getting the readings back.
Oh, cool.
Yep.
So there's a lot you could do with automation with even just the 7.5 or ideally the 15 watts.
For sure.
And a USB connection.
Very cool. Well, Jason, where can people find out more about you and what you're working on and everything?
Yeah, well, you can find me on Twitter. My handle's at AscendedDaniel. And my website for all this hobby project stuff is reclaimerlabs.com. And I'm assuming we'll have links in the show notes.
Oh, yeah.
Yep.
And
you're hiring, aren't you?
We are hiring. So I know in particular, we're looking for a firmware engineer, electrical engineer, and a whole bunch of other positions. So if you check out castar.com, there'll be a link to the jobs or careers.
No, come on. We want direct email to bypass, HR. Come on.
Yeah, well, my email's... no.
Put him on the spot, huh, Dave?
No, we'll put a link in the show notes.
He blinked. That's okay. We don't blame you.
Yeah. We have a very good track record here on the Amp Hour of finding people for companies. So, yep. We should be charging a fee.
Maybe, yeah. Well, Jason, thanks for telling us about all this stuff. I'm really excited. This USB-C stuff, I think it's really great that you're helping open that stuff up. It was definitely daunting when I first looked at it.
Yeah, it looks complex.
The fact that you dealt with those 4,000 lines of code before I ever had to think about it, I do appreciate that.
Yeah, well, you're welcome.
All right, thanks for joining us, mate. It's been good.
Yeah, thanks for having me.
All right, we'll talk soon.
Catch you next time.
Bye.